concrete form design 2, and we have 3 learning objectives: determine design load for lateral braces, design wall and column forms, so basically the vertical forms, and then design lateral bracings for walls and column forms. So let's discuss for B, design wall and column forms first. So for the designing walls and column forms, just based on what we did in concrete form design 1, when we determined the form for slab, that in problem 3 of the previous lessons, the process will be similar, and it will be a lengthy process to do the design for wall or column forms, as we saw that in slab forms in the previous lesson. So what should be the process to design the wall or column forms as shown in here? First, we determine the maximum lateral pressures. So basically the concrete pressure applied on the vertical form. In the slab form that we learned in concrete form design, we determine the design load, including the dead load and live load of the concrete, of the formwork, that is the dead load, and the live load of the machine equipment on the formwork. So that different type of pressure that you have. So in the wall form, we need to determine the concrete pressures that we learned in the previous lesson. And then we determine the required thickness of sheathing or stud spacing. So either they give us, or we choose the stud spacing and we determine the required thickness of the sheathing, or vice versa, give us the thickness of the sheathing, then determine the stud spacings. Similarly, the next step, we require the size of the stud. So for example, after design, we determine that it's 2 by 4 inch of cross section, or we can determine the well spacings. And then similarly, instead of determining the well size, we can determine the tire spacing and check for the tire load. And to get into that, what is the stud, what is the wells, what is the tie, that I'm going to show a few slides next. So this is concrete form design 2 with some slide that you have. So this is the wall forms, and you can see. So you have the sheathing, and then you have the vertical member that we call that is stud, and the horizontal member, and you can see there, that is the wells. And in this case, you see the well are double, 2 members in there for the well. So that typical members and how it's organized for the wall forms, and that you can see it in here with the plywood for the sheathing, and then stud vertical, and the wells in this case double, and horizontal, as you can see in this wall form. So to step the wall forms, there can be 2 scenarios. The first one is the wall form with studs. So that what you see in the previous 2 photos of the real project. So you have the sheathing and you have the vertical stud, and then you have the well, and then you have the brace or strut. So that is the complete, all the members included. However, if the pressure is not so high, we can eliminate the strut. So basically, the concrete pressure transfer the load onto the sheathing and directly onto the wells without stud. So with that one, it go to the next one, wall form without stud. So as you can see, you have the concrete pressure, you have the sheathing, and then you have the wells, and the wells go to brace or strut. So no stuck in this form. So it depends on the question. The way that it works is different. Just like when you design the concrete, you have a 2-way slab or 1-way slab. So it have beam at both sides or only one side, as you can see. So similar to the form in these problems. So depends on the type of material. If it's not plywood, then you can use this table available on final exam reference for different wood or timber. You can be able to determine the maximum allowable stress for bending, FB, maximum allowable stress for shear, maximum allowable stress for compression, where the face range parallel to perpendicular to the support, FC, compression stress for parallel to face range parallel to the support, FV, allowable stress for tension, and it is modulus of elasticity. And it also has the reduction factor, depends on the wet condition and how it load over time. So with that, we can go back to problem 1 for today's lessons. Before we do the problem 1 for today's lesson, I can, in the next video, I just want you to see what we learned here. In today, it can be used, the concept we learned in slab form design in problem 3, for concrete form design 1, for yes problems for the wall forms or column forms. How? So I put the analogy here so that you can be able to figure it out. So if in the previous lesson is sitting, that is plywood or wood, then it on the wall form or column form, it's also sitting. What we call it a joist in concrete form design 1, then it becomes stuck in today's lesson for vertical form. What we call stringer in the slab form design, in the previous lesson, it become a well in wall forms or column forms. And then what we call shore in the slab form design, then it become a tie in wall forms. So with that one, you can see the analogies. In the next video, I just walk through the solution for problem 1 for the wall form design, because that's similar to problem 3 that you learned in concrete form design 1 last week.